daughter structure?
No, sir.
No, sir. Wait a minute. Let me see. It has been long since what we have studied. And all this bonding in carbon, the covalent bond, covalent bond. Okay, okay, okay. Let's go. So basically, this electron daughter structure we have studied. You will study in class 11th also. Now, there are two types of bonds. Bonds are of two types. Bonds are of two types, and one is called sigma bond, and another is pi bond. Sigma bond and pi bond. See, all single bonds are sigma bond. All the single bonds are sigma bond. Like if you have studied this structure or draw this structure, then this is your single bond. This is your single bond. You can see all are single bond. That means all the bond, this is sigma, this is sigma, this is sigma, this is sigma, and this is also sigma. This is called double bond, in which one will be sigma, another will be pi. Are you getting my point? One will be sigma and another will be pi. And if you are going to draw the structure of nitrogen, you can see this is your triple bond. This is your triple bond that we have studied in the previous class. And you can see in which one will be sigma, another two will be your pi bond. Is that clear?
Yes, sir.
So I'm going to write here pi bond existing double and triple bond. Pi bond existing double and triple bond. Now in double bond, you will have one sigma and one pi. In triple bond, one sigma and two pi. Is that clear?
Yes, sir.
So whenever there will be question, calculate the number of sigma and pi bond, you just need to write the whole structure, complete structure. Show every bond between every atoms, and then you can see if there is single, that means sigma. If there is double, that means one sigma, one pi. If there is triple, that means one sigma, two pi. Now we are going to talk about versatile nature of carbon. Versatile nature of carbon. See, this versatile, you should understand this, and you know that the compounds of carbon are very, very large in the universe. Most of the compounds that exist in our universe is of carbon. So there are two reasons why why carbon is versatile in nature, and the first one is basically it is called catenation. Catenation, and catenation is a tendency or which has ability to form bonds with other atoms, or also it can form bond with itself either in long chain also, or uh, closed compound. It can also form closed compound. And the next is basically its tetravalency. So first we are going to focus on this catenation property. So I'm going to write carbon has unique ability to form bonds. Carbon has unique ability to form bonds with other atoms of carbon, which gives rise to large molecules. To large molecules. And this property is called catenation. and this property is called catenation. Is that clear?
Yes, sir.
Please do that. Please do let me know when you are done with this.
Done, sir.
Very good. Now see, this is the first condition for your uh, versatile nature of carbon. Now we are going to see the second reason, and that is tetravalency. Tetravalency. Well, let me write it. That is your tetravalency. As you can see, what is tetravalency? Since carbon has 4 electrons in its valence shell, so it is called tetravalency, and it is capable of bonding with 4 other carbon atoms or atoms of some other monovalent. Monovalent, do you know what is monovalent? Which has one valency, that like hydrogen, chlorine, we can say fluorine. So we can write since carbon has 4 valency. Since carbon has valency of 4, please do write with me. It is capable of bonding with 4 other atoms of carbon. 4 other atoms of carbon or atoms of other monovalent element. So please do write it.
Done, sir.
Very good. Now, this is your tetravalency. So do you have any doubt up to this? No doubt? Azaan? Okay. So let's
Yes, sir.
start a new topic. Is there any doubt that you have?
No, sir.
Okay. Let's start a new topic, that is your hydrocarbon. Now see, first of all, I'm gonna define what is this hydrocarbon. Hydrocarbon is any compound in which a compound in which only carbon and hydrogen is present. Only carbon and hydrogen is present. That compound is known as hydrocarbon. Is that clear? Like if you are gonna say this is CH4, it is hydrocarbon. C2H6, that is hydrocarbon. C2H2, that is hydrocarbon. C2H4, this is also hydrocarbon. So a compound in which only hydrogen and carbon exists, that is called hydrocarbon. Is that clear?
Yes, sir.
Okay, I have a question for you. Can you tell me how many bonds does carbon form? How many bonds does carbon form? That means, yeah, it's a good question. Can you tell me how many bonds carbon form?
Sir, 4.
4. Always remember, that's good. Good. Carbon will form only 4 bonds, not more than 4 bonds. And if it is forming less than 4 bonds, that means it is not stable. Are you getting my point?
Yes, sir.
Okay, let's start. This hydrocarbon, that I'm going to denote this with HC. HC, that stands for hydrocarbon, is of 2 types. One is saturated hydrocarbon and another is unsaturated hydrocarbon. So as you can see, what is this saturated hydrocarbon? Saturated hydrocarbon, that means basically bond between bond between carbon and carbon is single. If in a saturated hydrocarbon or or basically in a hydrocarbon or hydrocarbon derivatives, there is a term that is hydrocarbon derivatives that will be used in higher classes. Basically, hydrocarbon derivative means hydrogen, carbon, hydrogen, and there will be any other element, also other element like nitrogen, oxygen, chlorine. That is called hydrocarbon derivative. After carbon and hydrogen, there will be other atoms. Is that clear?
Yes, sir.
Okay, so come to this point, saturated hydrocarbon, that means the bond between carbon-carbon is single. Unsaturated hydrocarbon, that means the bond between carbon-carbon, carbon-carbon, either it will be double or either it will be triple. So if the bond between carbon-carbon is triple or double, that means it is unsaturated hydrocarbon, and saturated hydrocarbon is the one which has single bond between carbon. Bond between carbon-carbon is single. So first of all, you are going to write it, then I will explain it in other. Let me know when you are done with this.
Okay, sir. Done, sir.
Very good. Now see, if the bond between carbon-carbon is single, that is known as basically your alkane, that is saturated hydrocarbon. And as you can see, you have unsaturated saturated hydrocarbon is of two types. If the bond between carbon-carbon is double, that means alkene. And if the bond between carbon-carbon is triple, that means alkyne. Is that clear? Now I'm gonna give some
Yes,
questions.
sir.
I'm gonna give some question. Please do write up to this. Classify the following as saturated and unsaturated. Can I change the slide?
Okay, sir.
You know the bond line structural formula, yes or no?
Yes, sir.
Very good. BSF, you know this. What is this? You know this. How many carbon present in this? Azaan, how many carbon present in this?
Sir, 2.
Okay, you don't know the BSF. You haven't studied it, right?
Yes, sir. I don't think so.
Okay, then why you told me you know the BSF, right? Again, I'm going to give you the same. So you need to solve this. Please do this. Which one of following is saturated and unsaturated? Azaan, are you done with this?
Done, sir.
I'm gonna write the answer. This is your saturated. This is your unsaturated. This is also your. Tell me about the third.
Unsaturated.
Unsaturated. This one,
Unsaturated.
it's saturated. I'll explain it. Tell me this one.
Saturated.
What you have written in your notes? Unsaturated.
No, sir.
Okay. What about the sixth one?
Sir, this one unsaturated.
Oh, there is wrong in this. No, it's not, and it's unsaturated. Okay, tell me, is it alkane, alkene, alkyne?
Yes, sir.
This first one, saturated means bond between carbon, carbon is single. That means saturated. That means it is alkane.
Yes, sir.
Tell me about this. This is alkene, alkyne, what?
Alkene, sir.
Alkene, double bond between carbon, carbon. What about this?
Alkyne.
It's alkyne. Because you know that there is two carbon and one hydrogen to each carbon. And we know that carbon forms four bonds and making only one bond. So we are going to put triple bond. Okay.
Okay, sir.
Now tell me about this. This is saturated. See why it is saturated. There is a carbon. There is a carbon. This carbon has three hydrogen. So it is making three bonds. It only needs to make one more bond. So it will form only one single bond. Now it is satisfied. The left carbon is satisfied. After this, you can see this carbon, the middle carbon has two hydrogens. So it will have two hydrogen. Now this carbon, middle carbon is also forming three bond. This bond, this bond, this bond, three bond. So it will only form single bond with this carbon, and now this carbon is forming triple bond with nitrogen. Okay, so what we see, the bond between only carbon and carbon, not with carbon and hydrogen, not with carbon and other elements. Are you getting my point?
Yes, sir.
So that's why it is saturated. In this way, you can see this carbon has three hydrogen as this, and there was there is another hydrogen. Wait a minute, I'm just sharing. There is another hydrogen. Wait a minute. Can you see the screen?
Yes, sir.
So as you can see, this has 3 hydrogen, and there is another carbon this, so it will make only one bond and hydrogen, and this is, so it is saturated between this, the bond between carbon is same. Is that clear?
Yes, sir.
Okay. And this is unsaturated hydrocarbon, as you can see. uh, this carbon is making has 3 hydrogens, so it will form hydrogen only form single bond. After this there is a carbon that is single, and then another hydrogen you have, then a carbon which has one other hydrogen. After this carbon, please write triple air 3, and this has 3 hydrogen. So in order to satisfy this carbon's bond, we will have to make double bond. Okay. Can I change the slide?
Yes, sir.
Okay. Now you need to calculate the number of sigma and pi bond in following. Please do solve it.
Yes, sir.
Calculate the number of sigma and pi bond in following.
Okay. Done, sir.
Okay. So let me know how many sigma bonds present in this. Okay. Yes, can you send me your answer for sigma bond and pi bond in this? Azaan, 12 sigma bond. Let me check. So as you know, this will have 3 hydrogen as this, and after this carbon has 2 hydrogen, and this carbon has 2 hydrogen as well, and this carbon has 3 hydrogen. So I'm gonna count this 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 sigma, and pi bond is 0 pi bond. Yeah, can you tell me about this? Just reply me in chat box. Tell me about this sigma or pi bond. Number of sigma and pi bond. 19 sigma bond. Let me say 3, 4, 4 to 6, 7. Oh, there was 2 hydrogen. I forgot to write. Can you tell me again? Sorry for this. So I'm gonna write this as 3, 4, 6, 7, 9, 10, 12, 13, 15, and then 16 and 319. Very good. Now come to this. How many sigma and pi bond present in this? One sigma, two pi. Very good. Can you tell me about this? How many sigma and pi bond? Very good. About this, E. How many sigma bond in E? Very good. Tell me about this. Sigma and pi bond. 9 sigma, and what about pi? Yeah, it's wrong answer, I think. 3 pi. See, there will be, I think 12 sigma bond is there. I'm gonna write the structure. So this is your C, 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 C. 5 carbon, total 6 carbon is there. So this is your C. All are singly bonded. You can see these are sigma bond, in which you can see this is your double bond. That means 3 pi is there. Now the sigma is 6, but hydrogen is also making single bond with each carbon. So total sigma, can you tell me now? Total sigma? Total sigma is 12. So 12 sigma and 3 pi. Very good. Now moving to the next part, which is we are going to specifically talk about hydrocarbons, that is alkane. Do you know the general formula of alkane is CnH2n plus 2. That means basically if you are going to put the number of carbon 1, the number of hydrogen will be double the number of carbon plus 2. That means if I'm going to put carbon 1, the number of hydrogen is double the number of carbon. 2 into 1, 2 plus 2, that will be 4. If you are going to put the number of carbon 2, so the number of hydrogen will be 2 to the 4 plus 2, that is 6. So can you write the C3 for 3 carbon, for 4 carbon, for 5 carbon, for 6 carbon? So you know what you need to do. It's very simple. 3 carbon, hydrogen will be double the number of carbon plus 2, that is it will be 8. Now 4 carbon, that means double the number of hydrogen plus 2, that will be equal to 10, and here it will be equal to 12, and here it will be equal to 14, because the number of hydrogen in an alkane will be the double the number of carbon plus 2. Is that clear? Is that clear? Azaan, please do
Yes,
respond.
sir.
Yeah, very good. So number of carbon I'm going to write here and its name. So whenever number of carbon is 1, that is in organic chemistry we say meth. We say meth. And when number of carbon is 2, 3, 4, 5, 6, 7, 8. So the number of carbon is 2, that means eth. 3, that means prop. You have to remember this. 4, that means bute. 5, that means pent. 6, that means hex. 7 that means hep, 8 that means opt, and if it is 9 that means non. If it is 9 that means non, and if it is 10 that means dec. So this is the organic nomenclature of carbon. If you have one carbon, meth, and the rest part, whether it will be ane, we have three parts: alkane, alkene, alkyne. So if you are going for eth, if the number of carbon is 2, that means eth. But it depends on the nature of bond. Whether it is single, then it will be known as ethane. If it is double, that means ethene. If it is triple, that means ethyne. So how we are going to recognize? We can look at the formula and we can recognize it, or we can write the structure, whether it will be single bond, double bond, triple bond, from where you can easily say that it is ane, in, ine, depending upon the nature of the nature of bond. Is that clear? Please do write it. Let me know. Let me know when you are done with this.